But it was.
So these are pretty similar to last week, but now we're just going to have inequalities, which makes it so there's a range of answers more often than not. So same thing. Well, actually, first we're going to do step 1 is solve as an equation. So we'll do absolute value of x plus 2 equals 2. So it means we have x plus 2 equals 2 or x plus 2 equals negative 2. So x equals 0, x equals negative 4. So then for an inequality, our answers can be graphed. And what I would say to do here is figure out what your two specific points are, and those need to be on the graph. So we get negative 4, negative 3, negative 2, 1, 0, 1, negative 5. And then back to algebra 1, we got to put circles on negative 4 and 0. Are they open or closed?
Closed.
You got a 50-50 chance and you hit it. So if it's less than or equal to or greater than or equal to, it's a closed circle. So this little bar here tells you if it's an open or a closed circle. So then what we'll do here is we'll just pick 3 points, one on each side of our two critical values, our two answers, and then we check each of those. And we need to find which one of those will make the original inequality true. So we'll do absolute value of x minus 5 is greater than or equal to 2. That's not what I meant to do. Negative 5 plus 2. Absolute value of negative 3 is greater than or equal to 2. 3 is greater than or equal to 2. So that one checks. If we plug negative 1 in, we get 1 is greater than or equal to 1. Oh, that's supposed to be 2. That one does not work. Yeah. And then we would do the third one, 1 plus 2. And that one does check. So what that tells us about our answer then is all the answers to the right of the 0 and all the answers to the left of the 0 work for this inequality.
I think I remember doing this algebra 2.
I'd be surprised if you did it with absolute value, but you definitely did it.
Something with that.
Yeah, and then you definitely solved like two-step inequalities, multi-step inequalities.
Does that mean negative 4 is not part of the
Oh, I'm sorry.
solution set?
It is. I got distracted by my red dot. Okay. So we'll add 2. Same thing, we'll solve it like it's a equation. So we get 3x minus 2 equals -1, 3x minus 2 equals +1. Over here we get x equals 1. But if we plug those values in, and if we were clever and looked before we even started doing this, at this point right here, can you have an absolute value that is less than -1? Because
It can never be negative.
is always positive, so no solutions. So this one's a little funky because you can't really do plus or minus 0. So you just get 1 point at 0. So you want to check both sides here. If you plug 1 in, you can get 1 is greater than or equal to 0. If you plug -1 in, you get -5.
5 is greater than.
So they both check. So your answer then is just all real numbers.
Except 0. 0 doesn't work. Well, never mind, it does. I keep forgetting its absolute values.
And it's greater than or equal to, right? So then with radicals, it's also pretty straightforward. X plus 2 is greater than 2.
Square each side.
Square both sides. We get x plus 2 is greater than 4. So x is greater than 2. Make sure to check your solutions. So this is greater than 2, right? Not is 2. So if you did 3 there, is the square root of 5 bigger than 2?
No, I don't think so. Oh, it is.
Because square root of 4 is 2, right?
Yeah.
So anything above square root of 4 will be greater than 2. So this one holds true, but that's what you also have to be kind of careful here about thinking about what you plug in to check. Because it's not just 2 that you're plugging in on this one, because 2 doesn't work. So like 2.1.
2.1 doesn't work either. I tried it.
Should work.
I forgot to add 2.
So then our graph here. Open circle at 2, and x is greater. But you need to make sure you check for those extraneous solutions. Extraneous just meaning like it seems like the number works, but then when you plug it in, it doesn't work.